In this section, we're going to take a look at vertex form. So we've talked about how A, H, and K were able to shift the graph around, and we looked at some examples of moving the graph left and right. In this video here, what we're going to do is look at the formal equation for the A, H, and K, or the vertex form, I should say, and see what it tells us. So we have our standard form, which is ax squared plus bx plus c. We're going to call that the general is when we just have y equals x squared. A can't be 0, and it gives us some information, but not as much as, say, a vertex form could in certain situations. Vertex form tells us, one, the vertex of the graph. So the vertex of the parabola can be found by taking the h value and the k value. Notice that I have a negative h here. This is not negative h. So whatever the h value is here, this is opposite. So for example, if I had y equals 3x minus 4 squared plus 2, then the vertex would be positive 4 and 2. The number in the brackets with the x flips to its opposite sign. So if we had another example here, y equals 2x plus 1 squared minus 7. Again, this value here, the h value, will flip, and it will be negative 1 and negative 7 as our vertex. Again, the k value is the y value that stays the same. It's the x value, or the x value of the vertex, which is the h. That's the one that flips. As well, we have our a value. That tells us the direction of opening. So if a is a positive number, the graph opens up. So you're going to have that U shape opening upwards. If it's a negative value, then it's going to open down, and you're going to have that U shape opening downwards. Now, ignoring the positive or negative sign on the A, we just look at the A value itself without the positive or negative component. If A is between 0 and 1, then we have the graph compressing or getting wider. We're pushing everything down, which leads to the graph becoming wider. If A is greater than 1, then the graph stretches or gets narrower. At 1, we just have our standard parabola that goes over 1, up 1, over 1, up 3, over 1, up 5. The h value by itself tells us the horizontal translation, how much the graph has shifted left or right. If we have a x minus h situation, then the graph shifts to the right. If we have an x plus h situation, then the graph shifts to the left. And k gives us our vertical translation. That means up and down. If k is positive, everything shifts up. If k is negative, everything goes down. Now, sometimes when we're working with these graphs, we don't have to plot all the points. We don't have to make a full table of values. We can just get the general idea of what's going on based on the equation. So if we take a look at a couple examples here, we're going to do what's called a sketch. And so if you're asked to sketch, you don't have to put all the points and make a table of values. If you're asked to graph, then you would make a table of values. So here we're just sketching. I have y equals negative 3 times x minus 2 squared plus 1. So we have a vertex. Our vertex is going to be at 2 and 1. It's opening up, it's opening down because it's negative. And that 3 is going to make it stretch out and get narrow. So we're stretching. So what we have is just a rough sketch at vertex at 2 and 1. I'm not even going to use the grid lines here because some of you might be doing this on line paper or on blank paper. So we just have a vertex at 2, 1. So over 2 on the x-axis, up 1 on the y-axis. Maybe somewhere around here. There's my vertex at 2, 1. I'm going to label that. And then it's opening down and it's stretching out. So I'm just going to open it downwards. And I'm going to accentuate that stretch and make it really skinny, really to accentuate the fact that we're stretching it out. So there is my quick sketch of that situation. In the next case, we have y equals 1/4 x squared minus 3. Same idea, we're just going to pick our vertex, and then we're going to, in this case, compress the graph by the quarter. It's opening upwards, so we have a vertex here at 0. There's nothing being added or subtracted to the x, minus 3. And then our direction of opening we said was up, and it is a compression. So I'm just going to make these notes to help us. You don't have to make these notes once you're comfortable with this, but make sure you're always getting them right before you stop making little notes like this. So our vertex is 0, -3, so maybe somewhere down here. There's my 0, -3 for my vertex. And then it's opening up and it's wide, so I'm just going to accentuate the fact that it's really wide here in my drawing. And so maybe I have something like that. So we're just accentuating narrow or wide. We are opening in the right direction, and then we're just labeling the vertex just to give us an idea of what the graph could look like. So if we flip here, the next part, describe a graph. So if I have an equation y equals 2 times x minus 3 squared plus 4, we want to describe it. We're going to do a quick sketch of it, and then we're going to state the values that x and y can take. So if I take a look at this here, I have a description. It is opening upwards. Graph opens upwards because a is positive. It is also stretched by a factor of 2. And then it is shifted to the right 3. The negative, remember, shifts to the right. And also shifted up 4. And up 4. So there's my full description of that. And then I can make a little sketch. And again, I can just make some quick axes here. So I got my quick XY axes. We'll plot our vertex, which is going to be at 3, 4. Shifted right 3 and up 4. So I'm going to go -3 and 4. We'll say that's maybe right here. It's opening up and it's stretched, so it's going to be fairly narrow in terms of drawing a little sketch. So I'll make a little sketch here, and this is -3, 4, and that's my vertex. So that would give a quick little sketch of that graph. Now we also want to state the values that x and y can take. X belongs, so E means belongs, to the real numbers. Okay. What I've done there is I've made an R with an extra line in it. You could also just draw an R and then put a line in front of it like that. That's just a way to illustrate the real numbers. So this says belongs to, and this says real numbers. So basically, x can be any value. It can continue infinitely this way or this way as it expands out, left or right. So it's going to take any x. However, the y's are limited. Y is greater than, because it's opening up, so y is greater than or equal to 4. So because the y value of the vertex is 4, the y's have to be greater than or equal to 4. So that would be the values that x and y can take. X belongs to the real numbers, y is greater than or equal to 4. If you're not comfortable writing this little notation, you could just write x belongs to the real numbers. Now, we'll take a look at creating an equation from a graph. So here's a parabola. We got a vertex at negative 2, 2, and that should be positive 2 there. It goes through a point of 0, 0. So if you need to, mark that point off, 0, 0. So I have 2 points. I'll need 2 points of value to actually tabulate what's going on here. So we have our general formula, y equals ax minus h squared plus k. Well, we know h and k. Our vertex is h and k. So our h and k can be filled in. So y equals ax. Now it's negative 2 for my x value, so that means that the h value is going to be positive 2. Remember, the h value flips in the brackets here with the x. And then the k value is plus 2. Now, I have an x, a y, and an a that are not known yet. We need to get this down to just one value. Well, if I take another point from the graph, in this case here, I have the point that it goes through 0, 0. So there's my x and there's my y. I can plug those in. I can't reuse the vertex because I've already used that here. But if I pick a second point on the graph, I can fill that in. Not y, 0 equals. So I'll sub those in now. 0 equals a 0 plus 2 squared plus the 2. This is still 0. 0 plus 2 is going to give me 2. So I got 2 squared plus 2, or 4. That's actually better written as 4a plus 2. And the reason why I reordered that is because I want to make sure that you recognize this is multiplication. You can't do 4 plus 2. This is 4a times 4 plus 2. So I rewrote it as 4a. These aren't like terms. We can't add them. We'll move the 2 over to the other side. I'll have negative 2 equals 4a. And then I will divide both sides by 4. And that simplifies down to 1/2 equals a. So here's my a value. So the equation is, therefore, the equation is y equals negative 1/2 x plus 2 squared plus 2. Couple things to note. I use 0, 0 here and 2, 2 here. It will not always be that case where the numbers are the same. X and y won't always be 0, 0. It's wherever you have another point. Any point that you're given on the graph. This case here, I use the y-intercept of 0, 0 as my second point. And again, it just happened that the h and k and the x and y values were the same. That will not always be the case. In most cases, it probably won't. But you sub in your h, you sub in your k from your vertex, you sub in another point for x and y, you solve that for a. Again, be careful. This is not to be added. Bedmass rules still apply, order of operations. And then you'll get your a value, which you can then put in the equation. A value, h value, k value. All right, one more example here. We're looking at making an equation from a situation that we're given. In this case, a ball is thrown from a height of 6 feet. After 1 second, it reaches a maximum height of 22 feet. Create an equation for this situation and determine its height after 2 seconds. So we have a ball being thrown from a height of 6 feet. And after 1 second, it reaches a maximum height of 22 feet. That means the vertex is going to be here at 1 second and 22 feet. I'm going to just draw a quick little sketch of this graph. Now, because this is a real world situation where we're throwing a ball, we have time, we have the height of the ball. We're not going to have a negative value for the height because it's not going to go into the ground. And we're not going to have a negative value for the time because it starts at 0. That's when we've thrown the ball. So we're going to start our time at 0. So we just need to worry about the positive values on the graph. So it has a starting height. It's thrown from 6 feet. So it starts here at 6 feet. And then after 1 second, it's up at 22 feet. So this is 1 second. There's my 22. So vertex at 1 and 22. We're going to have something looking like this. I don't know exactly what. This is just a sketch, just to get an idea of what the graph could look like. Something like that. It's not even a really good parabola. It looks more like a straight line and then a curved line. But we get an idea where we're starting, where we're peaking, and then it's going to hit the ground at some point after 1. Now we can make an equation. So we got y equals ax minus h squared plus k. Fill in what we know. We have our vertex. We also have an xy value. This is 0 and 6, right? This point here would be 0, 6 on the y-intercept. So we have a 6 for y. We don't know a. We have a 0 for x minus -1 for our h value. Right, so it's -1 because it's a positive here. It flips in the brackets, squared, and then plus 22. Let's simplify this. 6 equals 0 minus 1 is -1. Squared is +1. So it's just 1a or a plus 22. Move the 22 over. 6 minus 22 equals a. 6 minus 22, that's going to give us -16. That's our a value. And now we can write the formula. The equation is y equals -16 x minus 1 squared plus 22. That's our equation. And now the second part asked us to determine the height after 2 seconds. So at 2 seconds, we have y equals -16, 2 minus 1 squared plus 22. The time that it happens at is 2 seconds. And we have y equals -16, 2 minus 1 is 1, 1 squared is 2, or sorry, 1 squared is 1, 1 times 16 is 16. So this just works out to -16 plus 22. -16 plus 22 is going to give us a value of 6. After 2 seconds, it's at a height of 6. Which makes sense because our graph should be symmetrical. So it took 1 second to get up, and so it should take 1 second to get back down to 6. So that's our 2-second point there. And again, my graph, or my sketch here is just a sketch. It's not an accurate graph. Do note, you could rewrite this equation a little bit. Instead of x and y, you could write the equation as the height equals -16, and then the time minus 1 squared plus 22. That is also perfectly acceptable as an equation. In this case, it might even make a little more sense.